This is Pre-Calculus, section 4.1 notes, part 2. We just have a little bit to finish up here in our exponential function section of 4.1. Whenever we talk about exponential functions, we always like to talk about compound interest at the same time because those topics are related. This is review from Algebra 2. Our compound interest formula looks like, and we usually say a of t, because t is our variable of time, is equal to p times 1 plus r over n to the n times t power. There are a whole lot of variables there, so let's review what each of these variables represent. A of t is the amount of money that you're going to have after t years. So this is at the end of your investment period. P, the principal, stands for the starting amount of money that you're investing. T is the time period in years. So I want to put a little note here. If T is in months, you must convert it to years. R is our interest rate. And remember, whenever we're working with interest rates, we always have to make sure that we have them in decimal form. So change to a decimal. And then n is the number of times the interest is compounded per year. So that's a critical part of the problem, and they have to tell us that information. So if they say that the interest is compounded annually, then that just means that n is 1. If they say it's compounded quarterly, that would be 4 times a year. There's 4 quarters in the year, so that's n is 4. Weekly, well, there's 52 weeks in a year, so that would be 52. Semi-annually, you sometimes hear semi-annually is twice a year. Monthly, obviously, would be 12 times a year, and daily would be 365 times in a year. You don't have to do 365.25. You can just do 365. Okay, so let's use this compound interest formula to do a little bit of a problem. Oh, I apologize, one more thing. The continuously compounded interest, this is also called the PERT formula. Looks like this. A of t is equal to P times E to the RT. So again, our A of t, that's our ending amount after our investment period is over. P is the principal, so that's the amount of money that we start with. T is the time in years, and R is the interest rate per year, again, as a decimal. So make sure when you're plugging that rate in, you are changing it to a decimal if it's given as a percent. This continuously compounded interest means that N is infinity, right? It is being continuously compounded over and over and over again. So basically that changes the compound interest formula into the continuous compound interest formula. If we go back and we look at that compound interest formula, it basically takes that 1 plus r over n to the nth power, and it just, turns that into e as n approaches infinity. Okay, so now that we have our two formulas, the last thing we're going to do is 2 examples. It says if $2,000 is invested at a rate of 7% per year, compounded semi-annually, find the value of the investment after 6 years. So let's write down what we know. We know our principal amount is $2,000. We know that our rate is given as 7%, but in the formula we have to plug it in as a decimal. So if we change 7% to a decimal, that's going to be 0.07. If we're compounding semi-annually, that means that n is 2, and we want to look at the value of this investment after 6 years, so t is 6. So we're going to use our compound interest formula because we have a compounding semi-annually factor in our equation. So we're just going to plug everything in. A of t is going to be equal to P, our principal amount, which is 2,000, times 1 plus our rate, 0.07, divided by our n value, semi-annually is 2, to the n times t. N is 2 and t is 6. So that's our exponent. Okay, and now we grab our calculator, and I want to make sure that we are typing this into the calculator correctly because we all have different calculators, and so the safest way to do this is to do it in a series of steps. And again, with your calculator, it's going to follow PEMDAS, so you want to start on the inside and work your way out. So the first thing that I would do is I would say 0.07 divided by 2, and then I would hit enter. Leaving that number on your screen, hit +1, and then hit enter. Leaving that number on your screen, you do your caret, and then it's going to be 2 times 6, which in this case, obviously we can do in our heads. It's going to be caret 12, but sometimes those numbers aren't as nice. And we hit enter, and then finally we're going to take that times 2,000, and we're going to hit enter. Okay, so at this point you might want to pause, try this out. The answer that you should get is $30,022.14 rounded to the nearest dollar. So your $2,000 at these conditions 6 years later would be $3,022.14. Our second example here is a compounded continuously. So that tells us that we're going to use the PERT formula because we are doing continuously compounding on this one. We're still going to write down the information that we know. Sally invested $4,450, so that's our P, at an APR of 5.5% annual percentage rate. That's APR. So our rate is 5.5%. When we change that to a decimal, move the decimal point 2 places to the left, that's going to be 0.055. Compounding continuously means we're going to use our E formula. What is the investment value after 4 years? So T is 4. Okay, so we're using our A of T is equal to P times E to the RT formula. So we get 4450 times E to the 0.055 times 4. And again, on your calculator, this one's a little bit simpler, but on your calculator, you're going to start with E raised to the 0.055 times 4, hit enter, and then you're going to take that value times 4,450 and hit enter. The answer that you should get is $5,669.65. If you are having any issues with your calculator or typing any of these in, please come and see me and I can help you figure it out.